Hello, everyone. Today we are going to talk about functions. We are going to start with definition. Definition. A function f is a rule that assigns to each element x in a set D, which is called also domain, exactly one element f of x in a set R, which is called range. I'm going to draw a little picture visualizing this kind of definition. So that's going to be my set D, and I'm going to put here domain. And color here is going to be my set R range. And here is going to be element X in the set D. Element X can be a number, can be some other object, for example, can be a student, for example, or student ID, or a car. It's not necessarily going to be strictly a number. We are dealing with numbers in math, but most likely can be something else. And somewhere here is going to be element f of x. And they are connected by a rule. So you tell like which f of x corresponds to this x. This rule is called function f. Also, each element is connected exactly to one element here. So one element in set D is connected to one element in set R. We cannot have something like this. The same element goes to two elements. That's a bad idea. So this is not going to work. So one element X goes exactly to one element f of X. What is possible actually? Well, imagine that you have two elements, x1 and somewhere here x2. Can element x2 use the same f of x? Yes, guys. For functions, it's a possibility. So we can have two elements coming into one f of x, but we cannot have one element going to two different f of x. Okay? And again, the set of x's is called domain, and the set of f of x is called range. We also going to call x independent variable. Well, why do we call it a variable? Because actually variable can take different values from this set. Variable change values, and set R is going to define y, which is dependent variable. From what it's dependent? Well, it's dependent from x, right? You set up x, and this way you define actually f of x. Okay, well, guys, how do we define functions? There are many different ways to define functions. For example, you can say function in words. For example, can be a relation between children and parents. So each child has one mother and each child has one father. I'm talking about biological parents. Okay, so that's going to be a function. We define it in words, right? Another way to define a function is to just set up a table. Table means that you kind of draw something like Excel table and say, well, this is my x's and this is my y's, and for each x you have one y, and that's a second way to define. So I'm going to write down different ways. Give me a second, guys. What I want to do. Color. So there are several ways to define a function. Well, verbally. We'll just say relation. Okay. Second, table. I'm going to draw a little example of a table. Here x and here y, and here you say 1 is equal to 1 and 2 equals to 4, for example. And you kind of say, okay, for this x, this y is going to work, and you can do more of them. What other ways you can do? Well, you can define a function as a graph. You can just draw the picture and something like this, and you say, here is my x and here is my y. And for every x, there is going to be just one y, and this is going to be the function. Can happen sometimes. And the last way is to define a function as a formula. Something like this. F of x equals 2x. So you kind of take any number plug it instead of x, and multiply by 2 and get f of x. Okay. I'm going to give you several examples of formulas to define a function, and we are going to try to evaluate functions. This I don't like. I think my pencil is too kind of thin. Maybe it's not very visible. Okay. We are going to prefer this way, the formula way mostly, but sometimes we are going to use the graph and the table, sometimes verbally going to define a function, especially in word problems. We're going to right now start with first example. Example 1. Yeah, that's my things. So let's imagine that somebody gives us a function as a formula. F of x equals 3x squared plus 1. And they're asking us, please evaluate this function. Evaluate means that find the values of a function for x equals 0, x equals 1, and x equals -1. Well, try to evaluate. What do they mean by the word evaluate? Means that they want us actually calculate what is f of 0. You just take 0 and plug it instead of x, and you're going to have 3 multiplied by 0 squared plus 1. Well, we know that 0 squared is still 0, 0 multiplied by 3 is still 0, so 0 plus 1 is equal to 1. We evaluated function at 1. Let's do evaluation f of 1, the next x over here. The same way, 3, 1 squared, instead of x, we plug in 1 plus 1. Now it's a little bit more complicated. 1 squared is still 1, right? Multiplied by 3 is 3 plus 1 is going to give us 4. And the last value, f of -1. Well, let's just kind of plug everything into our formula. Well, -1 squared equals 1, right? -1 by -1 equals 1. Minus disappears. By 3 is still 3, plus 1 is still 4. Well, you see, we have a case over here where two different x's, 1 and -1, give us same y, and that's normal for a function. It's not very good when we do have like 1x but two different y's. Next example is going to use a graphical way of setting a function. Let me draw a function, and we are going to do evaluation using the graph. My function is going to be a straight line in the first quadrant and a straight line in the second quadrant, which are bisectors. That's my function. And that's going to be my 1 unit here and 1 unit here and 0 here. And somebody is asking me, can you evaluate the function f of 1 and f of 2? And also f of -1. What are going to be the values? Well, f of 1, we see it from the graph that equals to 1, right? How do we know that's 1? Well, an x-axis, you look for 1, and then look at your graph and see what is y coordinate of a point. It's also 1, right? Now, at x-axis, we'll look for 0.2 for the next one and find out that y coordinate at 0.2 is also equals 2. How about -1? Well, -1 is somewhere here, right? If we go back to the function, we are going to see that the value of y is also equal to 1. So we evaluated the function using the graph. Very good. Now, as I said before, all possible axes or set of axes are making domain. And we can kind of find the domain using our math skills. Let's see how to find domain. Let's talk about domain and see how to find domain. I'm going to put in parentheses what is domain just to remind you. All possible x values. So, well, let's look at something simple. Example 3, f of x equals x squared. What are possible axes here? Well, which axis can we substitute here? Well, we can basically substitute any number here, right? So I'm going to say any real, real number. If somebody is asking us to express domain in interval notation, you are going to write down x belongs to the interval from negative infinity to positive infinity. Well, again, we can square basically any number, so there is no kind of question about this, right? A little bit more complicated example. Example 4, f of x equals 1 over x minus 1. Well, what are kind of problems with this function? Well, we know that we cannot divide by 0. There is no definition of what is going to be the result if we divide by 0. So restrictions on domain is going to be x minus 1 is not equal to 0 because it's going to give us division by 0, or x is not equal to 1, right? If you move this minus 1 to the right side. If you draw a number line, you're going to have over here 1. And all other numbers are kind of good, right? We can divide by any other number besides 0, and 0 is going to happen when x equals to 1. So how do we write down this domain in interval notation? In interval notation, you write down negative infinity to 1, and you are not including 1, and 1 to positive infinity. Or you can just write down all real numbers except 1, which is still going to work. My next example is going to be even more restrictive. Example number 3. F of x is going to be equal as square root of x minus 2. Square root, remember that we cannot extract square roots of negative numbers if we are in a real numbers math, right? Remember that we already kind of knew that basically roots of negative numbers are going to produce complex numbers. But if we don't want to deal with complex numbers, we'll need to restrict the expression under the square root to make it greater or equal than 0. So I'm going to write down x minus 2 greater or equal than 0. Otherwise, we are going to have a negative number, right? If I add 2 on both sides of this inequality, I'm going to get x greater or equal than 2, number line 2 here, and greater or equal than 2 is going to be to the right of 2. In interval notation, it's going to look like this. X belongs to the interval from 2 to positive infinity. Why do we include 2 here? Well, because the square root of 0 is 0, because we know that 0 multiplied by 0 is 0. So if you kind of extract the square root of 0, it's going to be 0. Okay. So we know how to find domains. Now I ask you to find several domains. My problems are a little bit more complicated. And again, guys, remember the rule. While I'm giving you a problem, you can stop my video and try to solve this problem on your own, and then start it again and see how I solve the problem. So self problems. And let me start. Problem 1. In all problems, I want you to find the domain. My first problem is 1 over 2x squared minus 4. My second problem, x equals square root of 4 minus x squared. And my third problem, I'm going to give some space over here, f of x equals x divided over a square root of x plus 1. In all 3 cases, I want you to find domain. Okay, well, you know that you can stop my video right now, and I'm going to count to 5 and solve the problems. So 1, 2, 3, 4, 5. So I'm going to solve the problems. I'm going to start with first problem. Let me change my color so you can kind of separate solution from the problem. And so as we look at the function, we see that we do have a denominator where sits x, right? And we cannot allow the denominator to be equal to 0. So I'm going to write down that 2x squared minus 4 is not supposed to be equal to 0, right? I'm going to solve this and move 4 to the right side, and that's going to give me 2x squared not equal to 4. And if I divide left and right side by 2 here and by 2 here, let me move it a little bit this way. I'm going to get that x squared is not equal to 2, or square root of x, I mean, not square root of x, but if I extract the square root of both sides, then x is not equal plus minus square root of 2. I'm taking the square root of here and the square root of here. Why do I have plus minus? Well, guys, we remember that generally the square root of any positive number can be this positive number or negative number, because you square positive number, you square negative number, you're still going to get that positive number. Generally, we use for problems positive value as a principal root, but for equations, we always consider both solutions. So x is not equal plus minus square root of 2. How do we write down this domain? Well, you can just write down all real numbers except plus minus square root of 2, or you can write it down like this. X belongs, well, maybe I should draw a number line before. This is my negative square root of 2. This is my positive square root of 2. So I can use all numbers here, and all numbers here. I'm going to start with left interval. That's negative infinity, and then minus square root of 2, unified with interval, minus square root of 2 to square root of 2. This one, the middle one. So one interval, 1 and 1. And last interval will go from square root of 2 to positive infinity. That's going to be like interval notation, and you can say, here you can say all real numbers. But x does not equal plus minus square root of 2. Sorry, my 2 too far, but that's going to be the correct solution. And I'm going to problem 2. Let me label that. This is solution of problem 1, solution of problem 2. Well, for problem 2, we will need to make expression under the square root greater or equals than 0. So 4 minus x squared greater or equals than 0. This is quadratic inequality, right? How I'm going to solve it? Well, guys, I'm going to factor my expression in parentheses. I'm going to write down that. Remember the formula. A squared minus b squared equals a minus b, a plus b. One of the formulas from chapter 1, right? So I'm going to look at this formula and see that my a is equal to 2, right? Because a square is 4. So I'm going to write down 2 minus my b is equal to x, and 2 plus x, and we want to make it greater than 0. Here I'm going to solve this inequality using interval method and test points. So solution of my first parenthesis, x equals 2, right? I'm going to write down 2 here. My second parenthesis equals to 0, and x equals negative 2. And I got 3 intervals, interval number 1, interval number 2, and interval number 3. I'm going to pick up one test point for each interval and check whether it's giving me positive or negative expression. I'm going to start with my left interval and use x equals negative 3. So negative 3 for here is going to give me 2 minus minus 3, which is 5, positive, right? And 2 minus 3, because it's plus minus 3, is going to give me minus 1. So it's plus here. Now I don't need this. Plus here and minus here. I'm going to just put minus. I don't want to give the value here. So totally we are going to deal with minus, and I'm going to put minus here. Well, for us, it's not going to be good, right? Now, next point to check x equals 0, which belongs to the interval from negative 2 to 2. 0 here and 0 here. Well, 2 minus 0 is 2 plus, and 2 plus 0 is still 2 plus, so the result is plus. I'm going to put plus here. And the last interval is from 2 to infinity. I'm going to choose x equals 10, just for fun. So 2 minus 10, obviously negative number. 2 plus 10, obviously positive number, and the result is obviously negative. So I'm going to put minus. We need interval where the values are greater than 0. So this one is going to work for us, and I'm going to write down that x belongs to the interval from negative 2 to 2. Why do I include both? Because square root of 0 is defined and equals to 0. So I can use actually minus 2 and 2. My last problem I'm solving is problem 3. Problem 3, I'm going to solve it over here, okay? Problem 3 is like a fraction. Well, here for the fraction, kind of restriction is that denominator is not equal to 0, right? And also that expression under the square root is positive, not negative. I'm going to write down x plus 1 is greater or equal than 0, and x plus 1 is not equal to 0. This one is denominator, and this one is a square root restrictions. So denominator cannot be equal to 0, and the square root cannot be extracted of negative numbers. When I look at these two expressions, I'm going to see that they kind of, well, the second expression excludes part of the first expression, because first expression actually allows us to have 0 here, right? Equals to 0. But second expression does not. So as a conclusion, I'm going to unify them into one expression, x plus 1 strictly greater than 0. Now I'm not going to bother about like denominator equals to 0. And that's going to give me x greater than negative 1. I'm going to write down interval notation here. Greater than negative 1 means negative 1 to infinity. Number line here, well, that's negative 1. And greater than negative 1 is to the right of negative 1. I'm not including negative 1 because if you plug in negative 1 here, you are going to get 0 in denominator. Square root, you can extract it, but you cannot divide by 0. Okay, well, that's all about this first section, kind of short video, and please do your homework.